Hello everyone, I'm Ishat, a second year PhD student at the CS department. Today I'll be presenting our work titled Fast Biconnectivity Restoration in Multi-Robot Systems for Robust Communication Maintenance. The work is done with Guangyao and Pratap. It has been submitted in IROS 2021. In this work, we focus on the fast biconnectivity restoration or the FBR problem. Before introducing the FBR problem, let me define a property of a graph called biconnectivity. A graph is called biconnected if at least two nodes need to be removed to disconnect the graph. In the FBR problem, we are given the positions of a set of robots and the communication radius such that the induced communication graph is connected but not biconnected. The goal of the FBR problem is to move the robots such that the communication graph becomes biconnected and the maximum distance a robot moves is minimized. The sensor networks community studied several variants of the FBR problem, but they optimized different objective functions. For example, sum of the distance traveled or number of robots to move. In this work, we propose a quadratically constrained program or QCP formulation of the FBR problem. The key ideas used in the QCP formulation is the big M method, which ensures that edges exist between two robots when the two robots are within the communication range of each other and vice versa. And network flow, which ensures that the communication graph is biconnected. The QCP formulation can be used to solve the FBR problem optimally, but only for small instances due to large number of constraints. To this end, we propose a lightweight two-phase approximation algorithm for the FBR problem. The first phase, which we call graph topology optimization, determines which edges to add to make the graph biconnected. To select the edges to be added, we propose the edge augmentation algorithm, which is based on block category. The second phase, which we call movement minimization, determines how to realize the edges selected in the first phase by moving the robots minimally. We propose two algorithms for the second phase, the sequential cascaded relocation algorithm, which is based on BFS, and an optimal algorithm based on QCP formulation. This gives us two heuristic algorithms for the FBR problem, EASCR and EAOPT. We compare our proposed algorithms OPT, EASCR, and EAOPT with two previous works, which we call block translation and cascaded relocation. We modify the existing work so that it fits our objective function. Results show that our proposed algorithms perform better than the existing algorithms in minimizing the min-max distance. Also, the EASCR algorithm provides a nice trade-off between minimizing the running time and the min-max distance.